Again, welcome to DSRT 734. In this lectures, we're going to discuss about the difference between permutation and also combination. These are the two techniques that we can use to count an items. So this is an additional topic again in probability and counting. And so our main objective is to determine the number of ways a group of objects can be arranged in order. So determine the number of ways a group of objects can be arranged in order. This is called permutation. And also to determine the number of ways to which several objects from a group. Now here we are choosing several objects from a group, but without regard to order. So this will be a combination. And also using the counting principles to find probabilities. And we can use the three higher rankings again to find it, and we'll go through it. So first we start with the permutation. Permutation is an ordered arrangement of objects. So here the orders is very important, how they are ordered. So normally with the form of permutation, we are going to use a factorial of any number. So here we just explain what is a factorial. So a factorial of a number, which is, we say factorial of n, it will be n exclamation point. It will be n times n minus 1 times n minus 2 times n minus 3, up to 1. So what we mean is that to find a factorial of 3 is 3 times 2 times 1, or 1 times 2 times 3, the same answer. So let's see an example here. A factorial of 0 by definition is 1. And also example 6 factorial, it will be 6 times 5 times 4 times 3 times 2 times 1. Or 1 times 2 times 3 times 4 times 5 times 6. The answer will be 720. Again, the reason why we're learning how to find a factorial because we are going to use it in the permutation formula. So 4 factorial will be 4 times 3 times 2 times 1. Now we have a question here, an example. And this example is a permutation of n objects. So we have an objective of a 9 by 9 Sudoku number puzzle. So this is 9 by 9 Sudoku number puzzle. Is to fill the grid so that each row and each column and each 3 by 3 grid contain the digits 1 to 9. And how many different ways can the first row of a blank 9 by 9 Sudoku grid be filled? So here we can see what we are trying to say is that we fill it 3 by 3 to contain the number from, again, 1 to 9. So example will be here 3 by 3, another 3 by 3. So in this case, we have 9 3 by 3. And we have 3 3 by 3. So for example, 1 2 3 rows, but also 1 2 3 columns. So together when we count it again is 9. Now the question said the objective of this 9 by 9 Sudoku number puzzle is to fill the grid so that each row, each column, and each 3 by 3 grid contain digits 1 to 9. So here should be 1 2 3 4 5 6 7 8 9. So each 3 by 3. Now the question is saying, how many different ways can the first row of a blank 9 by 9 Sudoku grid be filled? This is the permutation. Why is it? Because the order is very important. So the number of permutation is 9 factorial, because this is 9. So it will be 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And if you multiply everything, you get 362,880 ways. The orders are very important here. So what we mean here is that I can get 1, 2, 3, 4, 5, 6, 7, 8, 9. Next, I can get 2, 3, 4, 5, 6, 7, 8, 9, then 1. And next time I can get 4, 5, 6, 7. So the possible combination and the order is very important. It's a lot. Here over almost 400,000. because I can start somewhere in the center here with 1, then I can go 2, 3, 4, 5, and I can go 7 here, count 8, 9, then start next 1. So many combinations. So now we go to the permutation of an n object taking r at a time. Here we didn't take any r, so here basically we just said we have 9 by 9. How many possible permutation we can get with 3 by 3? We're still using the whole 9, 1 to 9, but in the arrangement of 1, 2, 3, 4 up to 9. Next time we can arrange it 2, 4, 5, 7. Next time 3, 9, 7, 6. It can be any order. So possible order is over almost 400,000. Now here, it's a little bit different now, and that's why we are using this formula. Here, for example, I have letters A, B, C, D, and I want to permute it into 3. So we have A, B, C, D is 4. I want to make it 3. So what is the possible order of 3 letters from 4 letters? So that's the formula we have to use. So in this case, N will be our 4, the whole letters, and R will be the 3 that I want to. So R always should be less than or the most is equal to N. Our first example, R and N are the same because we are using 9 and also the 9 possible combinations. So that's why we get 9 factorial. Because we get 9 factorial divided by 9 minus 9. 0 factorial is 0. 0 factorial is 1. So if the number of orders, let's say the first question here, we have 9 by 9, 3 by 3 grid here. What possible, the total is the whole 9, and also want to know how many 9 possible. So it will be R is 9, N is 9. So it will be 9 factorial over 9 minus 9 factorial, which will give us 9 factorial over 0 factorial. 0 factorial is 1, so the answer will be 9 factorial. But here, let's assume we have 9, but we want to take 6. That is 6, what is the possible combination of 6? The orders are very important. So A, B, C is not the same as B, C, A. They are 2 different. And we will come to combination. In combination, A, B, C, and C, B, A, they are the same because the order is not important. It's the number of units we have if they are the same. So here we say the number of different permutations of n distinct objects taken at R at a time will be this. So it will be n factorial, n minus r factorial. You see here we say the number of different permutations of n distinct objects taken where R at a time. So if n is 5 and I'm taking 3 at a time, then R is my 3. By the previous example, if I have 5, we use all the 5. So it's n factorial. So let's see an example here. They say find the number of ways of forming a 3-digit code in which no digit is repeated. So here we get NPR. Remember here we have how many digits? 10. Naturally we have 10, so they didn't even mention it here. They say find the number of ways of forming 3-digit code in which no digit. We know we have from 0 to 9, 10. So N will be 10. We are forming 3 digits. How many possible number of ways? So R is 3. So we get P 10, 3, which is 10 factorial over 10 minus 3 factorial, 10 factorial over 7 factorial. And we can see how they all cancel from 1 times 2 times 3 times 4 up to 7. Then 10 times 9 times up to, but it will cancel all the values up to 7. So our answer will be 9 times 10 times 8, which is 720. So which means if I have 10 possible digits and I take 3 and I want to know the possible combination of 3 from the 10 digits, it will be 720 ways. Now another question says find 43 race cars started the 2007 Daytona 500. How many ways can the cars finish first, second, and third? So here we have 43 cars, but our finishing should be only 3, first, second, third. So we're going to have N is the whole total of cars, 43. Or finishing, we need only 3. But these 3 can be any 3 from the 43. That's what we mean by permutation. So we're looking for permutation of 43 and 3. So it will be 43 factorial, 43 minus 3 factorial, which will give me 43 factorial by 40. So we know 40 factorial, it will be 40 times 30 now all the way to 1. 43 also be 43, 42, 41, then 40 to 1. So I'm going to cancel from 40 to 1 with a down. So it will let with 43 times 49. Sorry, 43 times 42 times 41. Again, reading the question, we have 43 race cars. We want to know the first 3 finishing. So we want to know the permutation of 3 cars out of 43. First, second, third. The order is important, so we have to use permutation. If the order is not important, we use combination. In combination, we are going to divide it with 3 factorial again to remove the order. That is, if I have A, B, C, C, B, A should be gone. So it will be 43 factorial divided by 3 factorial times 43 minus 3 factorial. That's for combination. So now, distinguishable permutation. Here we say the number of distinguishable permutation of n objects where n1 are of one type, n2 are of another type, and so on. We get n factorial over n1 factorial times n2 factorial that we down. So here we can write n1 plus n2 plus n3 up to nk is n. So example is given here. A building contractor is planning to develop a subdivision that consists of 6 one-story houses, 4 two-story houses, and 2 street-level houses. In how many distinguishable ways can the houses be arranged? So here we know the number of houses. There are 12 houses in a subdivision, because we can see subdivision consists of 6 one-story houses, 4 two-story houses, so that is 10, plus 2 street-level houses. So total for the number of houses is 12. But N1 is 6, N2 is 4, N3 is 2, based on the type of houses. 6 one-story, 2 stories, 4. Then we have street-level houses also 2. So we can see that the total we get 12. So now they say, in how many distinguishable ways can the house be arranged? So in this case, remember the formula here. We get n factorial, then n1 factorial, n2 factorial, n3 factorial, up to the sub. So the same, this is distinguishable ways the house can be arranged. 12 is total, so it will be 12 factorial divided by 6 factorial times 4 factorial times 2 factorial. And this will give us 13,860. So the last part is the combination. Permutation, the order is very important, so we include the order. For example, a combination will be, let's say we have 4 security guard officers that work in a company, and we want to put 3 people in one shift at a time. How many possible combinations we can get? Well, if I use Joseph, Emmanuel, and William, it's the same as saying William, Joseph, Emmanuel. The order of the people doesn't matter. They are the same people. So the possible combination will be, take the first 3, 1 is out, bring that one, take 2, bring the other one, take 2. So we'll see that we don't want to have the same 3 people at a time, more than once. But if permutation, the order of them is important. So if John comes first, and William comes second, and James comes third, next time James comes first, William comes second, and John, but the 3 are the same. That's for permutation. Combination, we don't care about the sequence. So that's that we use the R factorial to remove the sequence. So here we say a state Department of Transportation plans to develop a new section of interstate highway and receives 16 bids for the project. Now the state plans to hire 4 of the bidding companies how many different combinations? You see here we are using a company. So if I have company A, B, C, it's the same as saying company C, B, A. Company A is the same, so it doesn't matter what position. So mostly combination is good for combining something like a company, a person, because these are things that the order doesn't matter. So this is you need to select 4 companies from a group of 16. So N is 16, R is 4. Then the formula will be 16 factorial, 16 minus 4. If we hand it here, then we get permutation. But we're going to divide by 4 factorial again, so that the order, we don't have the same item for 4 items, but the order is different. The order doesn't matter. So it will be 16 factorial, 16 minus 4 times 4 factorial. If it's permutation, then it will be 16 factorial, 16 minus 4 factorial. And our answer will give us 1820. So let's try the next example, finding probabilities. They say a student advisory board consists of 17 members. 3 members serve as a board chairs, secretary, and webmasters. Each member is equally likely to serve any of the position. What is the probability of selecting at random the 3 members that hold each position? So here, let's say we have 9 or any amount, but we want to know 3 at a time. So there's only one favorable outcome. There are how many? 17. And 17 minus 3 factorial. And we get 40, 80 ways the 3 positions can be filled. Here we are not talking about the person. We are talking about the positions. So the order of the positions is important. So this is permutation. Now if we say, okay, we have 17 names, we give the names out, and we say how many possible combinations that actually the question said combination. Let's say how many possible we can arrange 3 members in this category. Now, if we are focusing on the people, we don't care what position they are holding, then we have combination. But here we care about the position. So I may have the same, let's say example, I may have John, Jerry, Mary. John is a president, Jerry is a vice president, Mary is a secretary. I may have the same 3 again, but this time Mary is instead of secretary, Mary is the president. So it's the same 3 people, but because the position changes, it's different. So that's why this is a permutation. We are talking about the position. Now, what's the probability of selecting the 3 members? So it will be, we already know the possible combination selection. So it will be 1 over 40, 80, which will give us 0.0002. Now let's try this example too. You have 11 letters consists of 1 M, 4 I, 4 S, 2 P's. Total will be 11. If these letters are randomly arranged in order, what is the probability that the arrangement spells the word Mississippi? So remember M is 4. I also is 4. And S and P are 2. So there's only one favorable outcome. Here we say 11 factorial, 1. Now the total is 11. Mississippi letters, the total is 11. Or we can check it one time more. This is distinguishable. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now, how many S's I have? 1, 2, 3, 4, P, 1, 2, I, 1, 2, 3, 4, then M is 1. So here we're going to have 1, 4, 4, and 2. So we get 34,650 distinguishable permutation of the given letters. So the probability of it now will be 1 over 34,650. Another example here, they say a food manufacturer is analyzing a sample of 400 corn kernels. for the presence of a toxin. In this sample, 3 kernels have dangerous high level of toxin. If 4 kernels are randomly selected from the sample, what is the probability that exactly 1 kernel contains a dangerous high level of the toxin? Now here we know we have 3. Let's go here 4. 3 kernels have dangerously high level of toxin. If 4 kernels are randomly selected from the sample, what is the probability of exactly 1? So this is what we are using 3 and 1. We have 4. So the possible number of ways of choosing 1 toxic kernel out of 3 toxic kernel is 3, 1. I have 3, choosing 1. Now the possible outcome of ways of choosing 3 non-toxic kernel from 397 non-toxic. This is 397, we're choosing 3, so it will be 397 and 3. Now, using the multiplication rule, the number of ways of choosing 1 toxic kernel and 3 non-toxic kernels will be C31 times C3973. So we get 3 times 10 million again, which is C3973. So 10,349,790. And when we multiply, again, we get 31 million plus. So the probability of selecting exactly 1 toxic of P1, then it will give us 31049,370 over, again here, 1,050,000,050, etc. God, that's 404. So that will be the conclusion of our last topic in probability before that's classical probability and empirical and subjective. Now in this session, we discuss mostly focus on what is permutation, what is combination. So in next lectures, which will be our new chapter, we are going to focus on the distributions now. So we have 2 types of distribution: discrete distribution, which means based on the random variables based on counting, then continuous distribution, which the random variable will be based on measurement. And that will be our next topic. So again, wish everybody the best. Thank you.